Welcome to the Crazy Hat Chemist. So here's another video on bonding. Let's get started. Bam! We're going to determine the hybridization and bond angles for number 4. What is number 4? Number 4 is water or H2O. Before you continue with this video, you need to have a refresher of 2 other videos. So 2 other videos are drawing the Lewis dot structures for number 4, that is water, and determining the molecular geometry for number 4. Here's a quick little review of those. In the lower left-hand corner there, you should see the Lewis dot structure for a water, okay? And then based on that, you should see that we have an AX2E2, okay, for its generic structure, and then we have 2 bonding domains and 2 non-bonding domains. The name of the 3-dimensional structure is bent or angular, and I'm going to show that to you right here. Okay, this is for water. The red is the oxygen in the middle, that's the central element. The white things are the hydrogens, the gray things are the localized bonding domains. And these 2 things right over here, the tan things, these are the lone pair of electrons on the central element. And I'll just face that just like what you see for the Lewis dot structure. Okay, this is a tetrahedral arrangement of electron domains. There are 4 domains around the central element. That's 1, that's 2, that's 3, and that's 4. Okay, so this is a tetrahedral arrangement of electron domains. But not all the electron domains are bonding, and that means that some of them are non-bonding, as is the case with 2 of these. Okay, some people think that it looks like a Mickey Mouse. Yeah, of course. Okay, so what we need to do is we need to get the hybridization based on this right here. So remember, you're counting the electron domains around the central element. So I'll do that here for you. There's 1, there's 2, there's 3, there's 4. In other words, I'm going to do S, P1, P2, P3. I'll do that one more time, turning this just a little bit. S, P1, P2, P3. So it's sp3 hybridized. It's bent or angular. It has 4 electron domains around the central element. So the generic geometry of this is tetrahedral. So it's a tetrahedral arrangement of electron domains. And with a tetrahedral arrangement, the bonding angles are 109.5. But if you watch the previous video with ammonia, you had 1 lone pair of electrons on it. And it was a tetrahedral arrangement of electron domains, and you got a bond angle that was less than 109.5. In fact, for ammonia, it's 107. So therefore, if I have 2 non-bonding pairs of electrons on the central element, and it's a tetrahedral arrangement of electrons, then I should have something much less than 109.5 and certainly less than 107. So this bond angle is the only bond angle we're interested in. And this bond angle here for water is 104.5 or 105 if you want to, and that would be fine. So let me give that to you. So we have the sp3 hybridization for water, and we also have the bond angle of much less than 109.5, but in the range of 105 for any bent or angular-like structure. Okay, hopefully that worked really well for you. Here's another crazy hat. This is kind of like a unicorn, I think, but it is a last-minute Halloween costume, but I imagine it like a unicorn. Either way you go, give me a thumbs up if you like that video, subscribe to my channel, and watch out for the unicorn!